Question 1, in a particular population, 15% of the people are left-footed. Soccer team of 11 players, including one keeper, is picked at random from the population. A is asking us to find the probability that exactly one left-footed player from the team. Give your answer correct to 3 decimal places. So let's just write down what we know here. So we have left-footed, which is a probability of 15%, which is the same as 0.15 as a decimal. So if I divide 15 divided by 100, I get 0.15. And that means then that a right-footed, the probability of being right-footed, is 1 minus 0.15, which is 0.85. So that's the probability of being left-footed and right-footed. In this question, I'm going to use my binomial distribution here to answer this question, which is given as n choose or, n being the number of trials, or mean the number of success, times p, which is the probability of success, and we'll go through all these now in a second, multiplied by q, which is the probability of failure, and that is to the power of n minus r. So let's fill that in and see what we have. So n is the number of trials. So how many times are we doing this? Well, I'm only picking one person. So it's going to be 1 choose 1. And the probability of success or being left-footed is 0.15, and that's going to be to the power of 1. And I'm multiplying that then by the probability of failure, which is being right-footed, which is 0.85. And that is going to be, my n is 11. Sorry, I have 11 players on the team, not 1. And I'm multiplying the 0.85 to the power of n minus r, which is 11 minus my 1, which is to the power of 10. And when I type that into my calculator, I get 0.3248. And they wanted to 3 decimal points, so 0.325 is the probability. Having a look now at part B, find the probability that less than 3 players on the team are left-footed. So think about this. So less than 3 players being left-footed could mean that none of them are left-footed. So I'm going to look now for the probability of none of them being left-footed. Or it could be the probability that only one of them is left-footed. Or I could have the probability of 2 of them being left-footed. Now it says less than 3, so I don't include the probability of 3. So let's go off and find the probability of these 3 outcomes. So the probability of no one being left-footed. Again, I'm using my binomial distribution, same as above. 11 players on the team, none of them being left-footed, so 11 choose 0. And 0.15 is the probability of being left-footed, which is success, to the power of 0. And I'm multiplying that by 0.85 to the power of 10, or 11 minus 0, which is 11. Now, I could have just done 0.85 to the power of 11, but I'm going to be consistent here using my binomial, so that's why I'm doing it out. And I get 0.1673 on my calculator. Okay, next one I'm going to do now is, so that's the probability of no one being left-footed. Now I'm going to find the probability of just one left-footed. So the probability of 1 is going to be 11 choose 1. Now, actually, I have this from up above, don't we? We have this answer from part A, so why make work for ourselves here? So I'm just going to rub that out, and I'm going to take my answer from part A. So from A, my answer there was 0.325. Okay, so saves me doing it out again. And my third one, probability of 2 of them being left-footed. So probability of 2 is going to be 11 choose 2. And probability of being left-footed is 0.15 to the power of 2 times 0.85 to the power of 11 minus 2, which is 9. And on my calculator, that evaluates as 0.2866. I then add those 3 because or in probability means to add. So when I add them together, I'm getting 0.7789. And the question again wants it to 2 decimal points this time. So that is equal to 0.78. So that's the probability of less than 3 players on the team being left-footed. And question 1C, the goalkeeper is left-footed. Find the probability that at least 8 of the remaining are also right-footed, or sorry, are right-footed. So what have we here? So don't forget we've 11 on the team, and the goalkeeper is left-footed. So that means we have a remainder of 10 players. So let's just state that. And what's happening with these 10? At least 8 of them are right-footed. So at least 8 of them means basically I could have 8 of them being right-footed, or I could have 9 of them being right-footed, or I could have 10 of them being right-footed. So that's what that is basically stating. At least 8 of them are right-footed. So I could have 8, 9, or 10. So I'm basically just going to find the probabilities of those. So I'm going to have the probability of 8 being right-footed, or meaning to add in probability, the probability of 9, or again means to add the probability of 10 being right-footed. So I just need to go off and find those probabilities. So let's do each one out separately. So the probability of 8 of them being right-footed is going to be, again, we've removed the goalkeeper, so it's not out of 11 now, it's out of 10. So it's 10 choose 8, and then my success this time is to be right-footed. So I'm going to go 0.85 to the power of 8 because I want to be getting right-footed players. Times then my failure, which is left-footed, and that's to the power of 10 minus 8, which is 2. And on my calculator, I'm getting 0.2759 for that. Probability of 9 of them being right-footed is 10 choose 9, and the success is 0.85 to the power of 9 times left-footed, and that's going to be 10 minus 9, which is to the power of 1, and that's giving me 0.3474 when I multiply that out. And just if you're doubtful, we're using the NC/OR button on our calculator here, the choose button. And finally, probability of 10 being right-footed is 10 choose 10. Again, you don't have to use this method because we could just put it 0.85 to the power of 10, but I'm going to use my binomial, and my failure is left-footed, and none of them in this case are left-footed because I have 10 of them and I want to pick 10 right-foots, and that is giving me 0.1969. And I want to add them together, so I add my 3 probabilities, and I get 0.8202, and the question here wants it to 2 decimal points, so therefore my final probability is 0.82, or 82% of them would be at least right-footed if there's 8 of them. At least 8 of them would be right-footed. Okay, moving on, question 2.